Hello, my name's Colin. I'm here to tell you about Internet Protocol version 4 or Internet Protocol v4 or IPv4. This is a breakdown as to what that is. So the Internet, you've heard of that. It's actually designed at the beginning to keep working even when partially damaged or when part of it was overloaded. Practically all networks now use internet standards, even if they're not connected to the internet, which most are. And if they use the internet standards, one of those standards is called Internet Protocol version 4. There are other versions available, as you might guess. We're just going to look at version 4 today. So the internet uses IP to make communication possible between the different devices on the network. It was proposed in 1974. We went through different versions between 0 and 3 between 1977 and 1979. And then after that, we got version 4, and that was the one that was widely adopted by DARPA and colleges and universities worldwide. So, how does this work? Every device, every computer on the network has a unique identifying number, and that number is called its IP address. IP addresses are 32 bits long, 32 ones and zeros, but we represent them by 4 decimal numbers, which are separated by dots, and the numbers must be between 0 and 255. So, for example, an IP address could look like this. It could be 123.87.250.5. That's 4 numbers between 0 and 255 separated by dots. So, because the IP address is actually 32 bits, we could have that number of unique addresses, which seems like a lot, but we've actually run out of IP version 4 addresses, so it's not quite as much as we would like. That's why we're going to some later versions. Having said that, we can still have some tricks up our sleeves to accommodate more devices than that by separating them up into different networks. Okay, so a little question for you. What is wrong with that particular IP version 4 address? If you haven't guessed already, it is. There's a number greater than 255. We're only allowed 0 to 255. What's wrong with this one? If you haven't guessed, it is. There's only 3 numbers. There should be 4 numbers separated by dots, not 3 numbers separated by dots. So, Internet version 4 standard splits up the IP addresses into 3 classes of networks, and these are identified by primarily the first digit. So if the first digit is between 0 and 127, that would define it as a class A network. If the next number is between 128 and 191, then that would make it a class B network. And if the first number is between 192 and 233, that would make it a class C network. We can divide our networks into something called subnets, and we do that using a subnet mask. We take the IP address and the subnet mask, and from that we can derive 2 things. One is the host ID and one is the network ID. The network ID defines which network it's on, and the host ID defines a unique number within that network. So the network ID is a section of the network, so the whole of the internet is a huge thing, and within that we can separate off different sections of the network using the subnets. Every device that shares the network ID that's physically connected together is on the same network. If we had different devices with different network IDs, they wouldn't communicate with each other. Within that network, then each device has its own unique host ID, or if it doesn't, then there'll be a clash. So we don't want that. So for everything to work properly, we want each device to have a unique host ID within its network ID. Here's an example. So if we look at subnet mask so every class has got a subnet mask associated with it. And when we talk about a class A network, we associate the subnet mask with that of 255.0.0.0. And what this means is that the first digit of the IP address determines the network ID, and the next three determine the host ID. Here's an example. So if we have an IP address of 101.10.20.30, and this is a class A, so the subnet mask is 255.0.0.0. If we line those two things up, then we can see where it changes from 255 to 0, which is after the first number, and we split the IP address up into those two. Then the one on the left of that line, first number in this case, defines the network ID, so we then fill in the rest with 0, so the network ID would be 101.0.0.0, and the host ID is the next three numbers. That defines that, which is 10.20.30, but of course we have to put a 0 to fill in the gap because we always need 4 numbers. So our network ID in this case is 101.0.0.0, and our host ID is 0.10.20.30. If we look at class B, then class B has a subnet mask of 255.255.0.0, and what this means is effectively that the first two digits of the IP address determine the network ID, and the next two determine the host ID. Here's an example. We've got an IP of 130.23.45.67. And the subnet mask would be 255.255.0.0. So if we see where that 255 starts becoming 0, that's after the second number. So if we divide our IP address like that, so after the second number, then and anything to the right of that is the host ID, anything to the left of that is the network ID. So therefore, in this case, our network ID is 130.23.0.0, and our host ID is 0.0.0.45.67. Every device that shares that network ID is on the same network as this device. And for a class C, the subnet mask is 255.255.255.0 or 255.255.255.0. So this means that the first three digits of the IP address determine the network ID, and the last one determines the host ID. You can probably get the pattern now. So if we split that into the table, if we look at the subnet mask, first of all, we can see that after the first three, it changes from 255 to 0. So we need to take our IP address and take the first three digits of that and then draw a line. Anything to the left of that is to do with the network ID. Everything to the right of that is the subnet mask. So in this case, our network ID is 193.98.76 or 193.98.76.0, and our host ID is 0.0.0.0, and then what's left, we bring that down to 54 down from the IP address. Okay. Here's another example. We've got an example of 192.168.3.27. That would make it a class C network because of the first digit. That means it should have a subnet mask of 255.255.255.0. That means that after the first 3 digits, we split it. So in this case, the 192.168.3 is the network. The 27-bit determines the host. We fill in the zeros to pad it out to 4 digits in each case, which makes the network ID 192.168.3.0 and the host ID 0.0.0.27 or 27. So remember, those are the different ranges for the class A, B, and C, and this handy table tells you how many different devices you could potentially have on each class. So if you've got a small network, then you would pick a class C. If you know it's going to be certainly under 256, actually you can't quite get 256, you're going to get 254 because there are 2 reserved addresses, a bit more on that later. And if you've got anything like, you can have up to 65,000 odd different devices on a class B, and you could have up to 16 million-ish devices on a class A network. This is the same kind of table, but in this case we've also included the subnet associated with each I class. By the way, we can't use 127.0.0.1 because that's something called the loopback address. That's another reserved address. We can't use 255.255.255.255 either. That's a global broadcast address, and we can't use the lowest and highest in our range. So if we had an IP of 192.168.0.0 in our example, then we couldn't use that, and neither could we use 192.168.0.255. Those are both utilized by the system as the network address and the broadcast address. So we can't assign devices with those IP addresses in that class C network. So it's totally possible to set up every computer on your network manually, and sometimes you might want to do that, but we normally give that to a computer to do, and that could be a server, and if it is a server, we need to make sure the server is running something called a DHCP or Dynamic Host Control Protocol. There's another video you can watch to see that if you'd like to find out more about DHCP and Internet Protocol version 4. In summary, every device on a network using IP version 4 has a unique address, and these are we represent these as 4 numbers separated by dots. Every device also has a subnet mask, and that depends on the class of the network, as does the IP address. We can easily find out what network we're on. So the subnets are splitting the big network into smaller networks, and these are derived from these. We get the network ID, which decides which network we're on, and the host ID, which decides which number we are within that network. Thank you for listening.